Welcome to Note Studio. In the last video, we have learned about two ways of expressing chemical reaction, that is word equation using the words and chemical equation using symbol and formulae. We have also learned about balanced and unbalanced chemical equation. Now let us study about balancing of chemical equation. Balancing of chemical equation. The process of making the number of different types of atoms equal on both the side of an equation is called balancing of equation. That means it is a process. We have to follow few steps to balance a equation. And we have learned that what is the importance of balancing a equation. The reason is, according to the law of conservation of mass, mass can neither be created nor destroyed in any of the chemical reaction. That means before and after the chemical reaction, the atoms remains the same, or the number of atoms remains same before and after the reaction. That means the mass of the reactant must be always equal to the mass of the product. Hence, we have to, or it is important to balance an unbalanced chemical equation. Okay, that's why we'll follow few steps. Let us consider one example. See, example 1. It is given like steam is passed over heated iron to form magnetic oxide of iron and hydrogen. Can you guess now the reactants and products here? See here, one is steam is passed over heated iron to form. That means this is, from here we are getting the products. Here magnetic oxide of iron and hydrogen are the products. Steam as well as iron are the reactants. Two reactants and two products are formed in this reaction. Now, how to represent steam? What is the formula? We know that the formula of water is H2O. The gaseous state of water is steam. Whether any equation or the formula changes? No. So again, for the steam also, we are using the formula H2O because just the state has been changed, but the atoms remains the same. Okay. For iron, what is the formula or symbol we are using? It is Fe. Now we got two reactants, one is Fe and H2O. Products, magnetic oxide of iron and hydrogen. Hydrogen gas is formed. Hydrogen gas is nothing but H2. Now the question is about how to represent magnetic oxide of iron. Let us study. Now this is the chemical equation. Okay, this reaction is represented as chemical equation using the symbols and the formulas. Now F is nothing but iron, H2O is nothing but here, H2O is in the form of steam. Then we are getting two products, Fe3O4 and H2 hydrogen gas. Fe3O4 is nothing but magnetic oxide of iron. Now this magnetic oxide of iron is a combination or mixture of two different compounds. One is ferrous oxide and another one is ferric oxide. Ferrous oxide is FeO formula. Ferric oxide is Fe2O3. When we combine these two, we are getting Fe3O4. Understood? Now let us study about the process of balancing the chemical equation. As I said before, we need to follow few steps to balance the equation. The first step is writing the skeletal chemical equation and enclosing the formulae in boxes. Skeletal chemical equation is nothing but we know that the chemical equation which is unbalanced. So that we have written here, but you can see one difference. Every like symbol and the formula is enclosed using the boxes, correct? We did not write like before. See here without boxes we have written the equation, but first step what we have followed, we have just used the boxes. Why? That is the question now. The reason is we should not add any number or we should not change anything inside this boxes. It remains as it is. We cannot write here, okay, let me balance this using, or here three iron atoms are there, so that let me write 3 here. No, it is not possible. Okay, we should not change anything inside the boxes. We should not touch. So that we are just enclosing these formulas and symbols using the box. Is it clear? This is the first step. Second step is listing number of atoms of different elements in the unbalanced equation. What we have to do? We have to list the number of atoms present in this equation. First of all, we'll find out what are the different elements present in this equation. Can you guess how many different elements are present? Elements are nothing but the simplest form of matter, right? Here, Fe is one element, another is hydrogen, another is oxygen. Can you find anything extra in the product? Any other different elements? No, no chances, right? What are the elements or the atoms are present in the reactant side? The same elements will be present in the product side also. We cannot add anything extra or we cannot delete it also, right? So now these three are the different elements are present in this chemical reaction. Okay, now we will count the number of atoms present in the reactant side as well as the product side. Now about Fe, that is iron, in the reactant side, that this is the reactant side, how many iron atom is present? Just one is present. But in the product side, here we have written, see, Fe3, that means 3 atoms of iron is present in the product side. Next about hydrogen, correct? In the reactant side 2 hydrogen, product side 2 hydrogen. See, hydrogen is balanced. It is already present in the same number or equal number both the side. Now let us see the oxygen. Is it balanced or not? In the reactant side, how many oxygen atom is present? Yeah, correct. Only one. What about in the product side, how many oxygen atoms are present? It is 4. Correct. Now, iron is not balanced. Oxygen is not balanced. Different number of atoms are present in reactant side as well as in the product side. Now, it is the time to balance this equation. It's very important to balance. Now, just we'll go to the step 3. What we have to do in the step 3? It is written, selecting biggest formula and balancing the element with the maximum number of atoms, that is oxygen. So, in this chemical equation, which is the biggest formula? Yeah, clearly we can understand. This is the biggest formula when compared to these things. This is the biggest one, Fe3O4. And which element has a maximum number of atoms? Now this is the biggest formula, and which element has maximum number of atoms? That is oxygen, right? 4 atoms of oxygen is present. Now we have to balance now oxygen first. In the reactant side, in the product side already number of oxygen atom is more, correct? Whether we have to write any extra number here, no need, already it is more in this side, in the product side. Now we have to balance the reactant side. What we are doing here, see, already it is mentioned like 4, we have to write number 4, see, this side, not here. Okay, when we write 4 here, okay, this side, that shows this 4 is for hydrogen as well as for oxygen. Clear? So the 4 is now for both of them. It is not just only for oxygen, it is also for hydrogen. And now for hydrogen, now how many atoms of hydrogen has happened now? Because of just adding just 1 4 here, we have to multiply it. 4 into 2. How many? Yes. Now how many hydrogen atom has happened here because of just adding 1 4 here? Yes, now the hydrogen atom is 8, oxygen is 4. Correct? We have tried to balance oxygen. Oxygen is balanced now. But before hydrogen was balanced, because of this just one number, now hydrogen is unbalanced. We'll try. Yeah, step 4. Balancing the remaining atoms. So remaining atoms we have to balance. We can do like several steps, but we'll balance everything in this only. Yeah, now before we have written here 4, because of it hydrogen has become 8. Now the time to balance hydrogen, correct, in the product side. When we write 4 here, again here this also is balanced. Now iron in the product side it is 3, but in the reactant side before it was just 1. Now we have to add a 3 here. Okay, now so this is one hit and trial method we have done. We have to check. Okay, check. That is the step 5. Checking the correctness of the balanced equation. We'll check now. Iron in the reactant side, after balancing we have written 3. Okay, 3. In the product side, already it is 3. Correct? It is 3. Then hydrogen, reactant side 4 into 2. 8 atoms of hydrogen. In the product side 4 into 2. Okay, we have to multiply this. It is 8. Oxygen 4. It is just 4, but in the product side oxygen is 4. What do you think now? Now this equation is balanced. Correct? Now equal number of atoms are present in both the sides of equation, that is in the reactant side as well as in the product side. Hence we can say that this equation is balanced now. Now the step 6 is, after balancing the equation, we can make the chemical equation more informative using the physical state. So that is mentioned here, writing symbols of physical state. We can use some symbols to mention the physical state of that compounds. Now for the gaseous state, we'll use the symbol G. Inside the bracket we'll write like small letter. For liquid we'll write L. Aqueous we'll write AQ. Aqueous is nothing but any substances which is in the solution form. When we add water, it becomes solution, right? So that is aqueous. Then solid we'll write it as S. So these are some symbols of physical state. Now for the same example for Fe. Can you see? Here it is mentioned as S. That means iron we have taken in the form of, what is the physical state of iron in this equation or in this reaction? That is solid. Solid. That's why it is mentioned as S. H2O. H2O. We have learned that steam is passed over the iron. Steam. Here, this is in the form of steam. So, gaseous form, G. We cannot write, why we are not writing L here or liquid? This is not the liquid form. This is the gaseous form because it was written like a steam. Okay. Then Fe3O4 again, it is solid and H2 is gas. So we can make one equation more informative using the physical state also. There are some other example also in this notes. You can refer. Okay, we can mention even the temperature as well as like a pressure. Okay, these also can be written. Some other conditions also we can mention in the chemical reaction. This is one of the very familiar equation for you. This is the photosynthesis process, correct? Carbon dioxide, water, in the presence of sunlight and chlorophyll. See, above the arrow mark we have written the condition, how this reaction is taking place. And these are the product formed and the physical state also mentioned. So now you don't worry about like how to find out all this. When you if you observe the statement or any explanation, you can clearly understand what is the physical state. With practice, you will get it. Okay. Now again we will recall the same example. Now do you remember this? This is iron. This is steam, magnetic oxide of iron and hydrogen gas. Now how to balance? First, what step we have to follow? We have to enclose these formulas, everything in the box. Right. And then what is the next step we have to follow? We have to see the biggest formula. This is the biggest formula. Then maximum number of atom in that formula. Here we can find oxygen. Before that, we have to count the number of atoms present in the reactant as well as product side. Now this is the reactant side, right? This is the product side. Okay. Now let us count the number of atoms. How many iron atom is present? 1. Hydrogen 2. Oxygen 1. Iron in the product side 3. Oxygen 4. Hydrogen 2. Now hydrogen is balanced, but iron as well as, see, iron here 3, here 1, oxygen here 1, here 4. These two are not balanced. Now how to balance? Again we'll practice. Number of oxygen atom is 4. Biggest formula and maximum number of atom is present for oxygen. So we'll start from oxygen. Okay. Now oxygen here in the product side, it has 4 atoms of oxygen, so that we are not writing any number here. But where the oxygen is present in the reactant side, so water or the steam has the oxygen atom. So here we need to balance. Here 4 number of oxygen atom is present, no? That's why we'll write 4 here. 4. Now this 4 is for hydrogen as well as for oxygen. We won't write anything inside the box. right? Because of just adding 4, see now how many oxygen atom is present in the reactant side? It has become 4. Yeah. Now successfully this is balanced. What is the case of hydrogen now? Before it was 2, now it has become 4 into 2, that is 8. But what about in the product side? It is 2. What is the step? We'll write here 4. Just add 4 here. 4 into 2 now? 8. Yeah, this is also balanced. Now iron. In the product side it is 3. Again we don't want to add the number here. In the reactant side it is less. So now to balance we'll write here 3. Now iron is also balanced. See now all the atoms are balanced. Now both the side, reactant side as well as product side, has equal number of atoms. Hence we can say that this equation is balanced. And finally, as per your questions, you can mention even the physical state also. If the question demands to write the physical state, then you can go for it. Here solid iron has taken, so we are writing the small letter S. Steam is taken, so we are writing G. This is again solid, small letter S. This is the gaseous form of like hydrogen in the gaseous form. So this is how we are balancing chemical equation. If you want more explanation about balanced chemical equation using different example, please comment below. Or in the next video, we'll study about chemical reactions, types of chemical reactions. Thank you.